Welcome to the Unit 3 test review. So let's go ahead and get started. For number 1, we want to solve the following system by graphing. The first thing you're going to want to do is rewrite your equations so that they are a y equals form. So what I'm going to do is I subtracted 2x from both sides, and then I divided by -4. So my equation is y equals 1/2 x minus 2. Always start with your y-intercept. In this case, it's -2. So I'm going to draw my first point at -2. Now, with the slope, it's rise over run. So I rise 1, I run 2. Rise 1, run 2. So here is my first line. I'm going to do the same thing for the second line. I'm going to rewrite this so that it's y equals -1/2 x plus 6. So this time my y-intercept is 6. So I'm going to go up to the 6th value, and I'm going to have, instead of a positive 1/2 slope, this is a negative 1/2 slope. So I'm going to go down 1 over 2, down 1 over 2. And when you are solving by graphing, you want to find the intersection of your two lines. And that happens to fall right here. So the solution to this problem is the coordinate point 8, 2. Now, when you are doing an inequality, you're going to follow similar steps. You want to get y isolated on the left by itself. So I'm going to first go ahead and take care of that. I subtract x from both sides, and then I divide by -1. Remember, when you divide by a negative number, you have to flip your inequality. So now it's y is greater than or equal to x plus 1. I always like to start with the line. So this line has a y-intercept of +1. So I'm going to go ahead and draw my line first. So it's going to have a slope of 1. So we're just rising 1, running 1, rise 1, run 1. Now, when I draw my shading, I'm interested in all the y values greater than that line. So I want to shade above on the y-axis. So the shading here should be everything above. Now I have a little bit of overlap. That's where my solution is going to be. That's why it's not showing up yet. But we're going to do the same thing for our second equation. So I'm going to first get y isolated on the left-hand side. My y-intercept is +10. So I have my first point at 10. And my slope is -2. So I am going down 2 over 1, down 2 over 1. And this, I am also interested in the y values greater than that line. So I'm shading above, and my solution area is going to be the overlap between the two shaded regions. Now, when you are given an inequality and you are asked to write the equations, it does not matter which one you pick first. So I'm just going to go with this point. I always identify the y-intercept. So the y-intercept of my solid line is going to be here at +1. I like to write that down as soon as I know what it is. Next, I want to identify my slope. Well, I'm going up 2 over 1, up 2 over 1. So that should be a slope of +2 over 1. So that's just 2x. Now you want your y to be on the left-hand side so that you can say, when I look at my y-intercept, I am shading everything below it. So because of that, I want everything to be less than or equal to my line. And it's an equal to because I have a solid line. Now let's do the same thing for the other one. My y-intercept is going to be -2, and then my slope is going to be down 1, 2, 3 over 2. So it's going to be a slope of -3 over 2. And again, I like to write my y on the left-hand side. And this time I'm shading everything above it. So the y values are greater, if I can find it here, there we go, greater than my line. For number 4, I'm going to follow the same procedure. I have a y-intercept of -1, and I have a slope of what looks to be -1. So I have -x, my y, and then I'm going to have, oops, let's find it first. And then I'm going to shade everything above it. So my y is greater then negative x minus 1. With my second line, my y-intercept is negative 2. This time my slope is down 1 over 4. Down 1 over 4. So it's going to be negative 1/4. So I should have y, negative 1/4 x minus 2. And I'm shading everything below this line. So I have y is less than or equal to my negative 1/4 x minus 2. You are going to solve 5 through 8 either using substitution or elimination. So let's look at number 5. Number 5 is already set up for substitution, so that's kind of what I'm going to follow. Y is equal to 5 over 3x plus 13. Personally, I don't love fractions, so what I'm going to do instead is I'm going to multiply this entire equation by 3. So I'm going to get 3y equals 5x plus 39. This is not a step you have to do. You can still work with the fraction and get the correct answer. But now that I have 3y, I see that I can replace this entire statement with 5x plus 39. So that's what I did. I substituted 5x plus 39 where there was a 3y. Gonna do some simplification. I got 7x plus 39 equals 81, which became 7x equals 42, x equals 6. Now that I know the x value, I'm just going to plug that in order to find the y value. I just plugged it into the second equation, so I got y equals 5/3 times 6 plus 13. Well, 5 times 6 is 30, divided by 3 gives me 10. 10 plus 13 is 23. So my solution is going to be 6/23. Now, number 6 appears to be set up for elimination. So remember, you want to eliminate a variable by having the same coefficient with opposite signs. So I'm going to multiply my top equation by negative 3 and my bottom equation by 2. I'm going to do the elimination by combining linearly. That gives me 0 plus 0 equals 0. Well, 0 equals 0 is a true statement. And when you end up with a true statement, you're going to get infinite solutions. Now, if it was a false statement, you would get no solution. Looking at number 7, there is any way you can go. I personally think I'm going to do elimination. So what I'm going to do is first set up my equations so that they can be eliminated. I'm going to multiply my top equation by 3, which gives me 6x minus 15y equals 6. And then I multiplied my bottom equation by negative 2. Before I did that, I went ahead and rewrote it so that it was x, y, answer. And that became negative 6x plus 14y equals negative 2. When I combine linearly, I get negative y equals 4. So I should have a y equals negative 4. So I used that value y equals negative 4 to plug into an equation. I picked the first one and I solved for x, and I got x equals negative 9. So my solution should be negative 9, negative 4. Now for number 8, it's a 3-variable system. So you want to solve for one variable first and work your way back up. So what I did first is solve for z by subtracting 9 from both sides, which gave me 4z equals negative 12. So z should equal negative 3. Well, now I'll use z equals negative 3 to plug into this second equation. That's going to give me y equals 8. Going to use 8 and negative 3 to plug into the first equation, which is going to give me x equals negative 2. Remember, you're going to write your answer as an ordered triplet. For number 9 and number 10, we are going to do matrix addition. So I have A, which is just matrix A, plus 4B. That means I'm taking every value in B and multiplying it by 4, which I have here. And then I add the entries together that are in the same position. So 1 and 4, 3 and 20, 5 and 8, which is going to give me my matrix 5, 23, 13, 19, 6, negative 7. Going to do the same thing for number 10, but this time I have 2A, which is the matrix given here, minus B, same procedure. I'm going to take the two numbers in the exact same position and subtract them, which should give me matrix 1, 1, 8, -7, 2, -5. For number 11 and 12, we are going to solve for variables. So I'm going to look at every value in the same position as my variable. So I have x. So 4 plus x has to equal -16. So that should give me x equals -20. And then I'm going to do the same thing for y. Y plus 5 is going to equal 7. So I should get y equals 2. Doing the same thing for number 12, I get -2 plus x is equal to -12. So I should get x equals -10. And when I do it for y, I get 1 plus y equals 8. So y should equal 7. Number 13 is a Gaussian elimination problem. The first thing you're going to want to do is write your systems as an augmented matrix. Remember, you're only taking the coefficients and the answer value. Once you've done this, it's time to decide what row operation you want to perform. Typically, I recommend starting with the value in the second row, first column. So what I'm going to do is I'm going to apply row 1 minus 2 row 2. So that's going to make this value become a 0. So what I like to do is go ahead and go in and write the multiples out so I can see them, and then do my subtraction. So 2 minus 2 is 0. -7 minus -6 is -1. -1 minus 2 is -3. -3 minus -2 is -1. Now that I have my 0 here, I move on to my next value. Well, I have a 4, so what I can do is row 3 minus 2 times row 1. So I'm going to go ahead and apply that. Again, I like to write my values above the number so I don't forget. And I always write the rows that I'm not changing first before I do any multiplication so that I don't get confused. Now I have 4 minus 4 is 0. -1 minus -14 is 13. 2 minus -2 is +4. And 7 minus -6 is +13. My last value that I need to change is this 13 here. So what I can do is utilize this -1 to do so. So what I did was row 3 plus 13 times row 2. Again, I wrote the two rows that are not changing. I'm going to write the multiplied values above, below, somewhere near the actual value. And then I'm going to do the addition. 0 plus 0 is 0. -13 plus 13 is 0. -39 plus 4 is -35. And -13 plus 13 is 0. Now, don't get confused. You are not wrong if you made it this far. When I write this out as an equation, I'm going to get -35z equals 0. And that's okay, because I can go in and divide on both sides by -35, and 0 over -35 is just 0. So z is equal to 0 in this case. Then I'm going to use this value to work my way up. So the next equation I get is not that one. I get -y minus 3 times 0 equals -1. -y equals -1. Y is equal to 1. And then I use both of these values to plug into my first equation, which should give me the value x equals 2. Your last step, again, is writing this as a coordinate or an ordered triplet. Now we are going to write a system of linear inequalities. So I already went ahead and defined your variables. I said x was the number of adult tickets, y is the number of child tickets, and I have an equation for the cost, $10 for adults, $5 for children, and they want to sell more than 600. Now, this doesn't say at least 600. If it said that, then I would have an equal to sign here. So it's 10x plus 5y is greater than 600. And they have a theater that can seat 100 people. So the combination of adult tickets and child tickets cannot exceed 100. It could equal to 100, it just can't be more than that. For number 15, I went ahead and defined X to be the number of adult shirts, Y to be the number of child shirts. I think it's students, but child is fine. What I will do first is the cost. So 15 adults, 10 for students. They want to raise at least $3,000, meaning they would be happy if they got $3,000. So 15x plus 10y is greater than or equal to 3,000, and they only have 250 shirts. So x plus y has to be less than or equal to 250. For number 16, make sure you're careful that you organize your equations so that they are in the form x, y, z answer. So when I write my augmented matrix, it should look like this. This is a problem you will be putting into your calculator, doing reduced row echelon form on, and you should get x is equal to -4, y is equal to 5, z is equal to 1, and the question asks what's the value of x plus y, so it should be 1. Now for 17 through 20, you're going to want to include your system of equations and your matrix along with your answer to get full credit. So I went ahead and defined the variables for us, so you do not have to worry about that. For my first question, on the first night of a Drake concert, StubHub collected $67,200 on the sale of 1,600 upper level seats and 2,400 lower level seats. That gives me an equation of 1,600x plus 2,400y equals 67,200. Doing the same thing for my other equation, I have 2000x plus 2400y is equal to 73,200. I'm going to put these values into a matrix, use my calculator to do reduced row echelon form to get x equals 15 and y equals 18. So the upper level seats were $15 a seat, a steal, honestly, and the lower level seats were $18 a seat. Looking at 18, I have x is the cost of a mild wing, y is the cost of a scorching wing, and z is the cost of the Jamaican Me Hot wings. So I have to take this student by student. So Gabriel had eaten 4 mild and 8 scorching, so that's 4x plus 8y equals $18. Lee had eaten 8 mild, 7 scorching, and 5 Jamaican Me Hots for $25.50. And then Christopher had 4 Jamaican Me Hots. Be careful because it's not in order. 4Z, 6 scorching, 6Y, 7 mild, 7X for a total of $21.50. I went ahead and put my values into a matrix, did reduced row echelon form. I got X equals 50 cents, Y equals $2, Z equals $1.50, and that corresponds to my cost for the mild, scorching, and Jamaican Me Hot wings. For 19, I have let X be the number of adult tickets, let Y be the number of student tickets, and I'm going to do my first equation based on the cost. So 6X plus 450Y equals $615. And then I had 110 tickets sold, so X plus Y has to equal 110. Again, in my calculator, I got X equals 80, Y equals 30, so we sold 80 adult tickets, 30 student tickets. For 20, you have to be careful because you charge a fixed fee. So every time they did a performance, they had a fee attached. So I had that as my X value, and my Y value is going to be the cost per trick. So for my first equation, they did 23 tricks and charged $16.70. So X plus 23Y equals $16.70. And then I had 18 tricks and $15.95. So X plus 18Y equals $15.95. Again, in the calculator, I get X equals $13.25. So their fixed fee was $13.25, and they charged 15 cents per trick.